All right, so we are still here with transformations, and now we're learning about translations. A translation is a function in which all of the points of a figure move the same distance in the same direction. So we would say that a preimage is translated along a translation vector. That vector describes the magnitude and direction of the slide if the magnitude is the length of the vector from its initial point to its terminal point. And we're not probably going to talk in terms of vector necessarily. What we are going to talk is in terms of a component form. So we're going to be talking in terms of the coordinate plane. It's helpful to write the vector in its component form, and that vector is written just like this right here. So it's got these strange brackets that look like this, and it's got an x, y coordinate in the middle of it, which describes the vector in terms of its horizontal component x and vertical component y. Okay? And you're going to see that right down here, which is in your notes as well. So in words, you would hear somebody say, we're going to translate a point along a vector, and we are going to add a to the x coordinate and b to the y coordinate. So this is what that looks like right in here. You would start at some point x, y, and then you would add the a from your vector to the x, and you would add your b from the vector to your y. Okay? So here's an example down here. They say you're at point -2, 3, right here. They're translating it along a vector 7, 4. So they add the 7 to the -2 and the 4 to the 3, and you get a new point of 5, 7, which is up here, 5, 7. So that would be p prime. We go from p to p prime. Okay. So let's look at this example down here. And in your notes, I have copied all of it in there for you, including the actual answer. You don't have to write it out, nothing. It's just all there for you. So for quadrilateral QRST with all those vertices, find the coordinates of the vertices of the image after a translation along the vector 7, 1. And they first draw out QRST. And then I really do love how they write this. This is great. They write out our initial points here, and then on the right side, they write the rule on top that we're going to take the q coordinate plus 7 and the y coordinate plus 1, and then down below, they write that out methodically. And then they go ahead and check that the image matches the prediction. And I don't believe that they actually showed us that. So you have to go ahead and plot it yourself and make sure it works. Now the next one is our practice. So if you have quadrilateral ABCD with those vertices, which one of these will have a translation along vector 5, -3? Go ahead and pause me and figure it out. Did you find that it was at A? Hope so. All right. Now we're going to move on to rotations. Okay. A rotation is a function that moves every point of a preimage through a specified angle and direction about a fixed point. And they call that point the center of rotation. So if you want to go ahead and underline something, a center of rotation, that's a good one too. Under a rotation, each point and its image are the same distance from the center of rotation. Each point and its image are the same distance from the center of rotation. All right, and I went ahead and bolded this on your notes, but you can assume that the origin is the center of rotation in this lesson, okay? The origin is your center of rotation. We're not going to change that up on you or make it funky. We're going to go with the origin. The specified angle is called the angle of rotation. Okay? Now, the direction of rotation can be clockwise or counterclockwise. In this course, you can assume that all rotations are counterclockwise unless stated otherwise. Okay? And this one is your chosen one. The reason is because when we do, let's see, our coordinate plane, you might remember, but we call this the first quadrant. And do you remember where the second quadrant is? Let's see. First quadrant. This one is our second quadrant. Here's our third. Here's our fourth. So as we move through them, we go this direction. That is our positive direction. So if we rotate 90 degrees, it's assumed that that is a positive 90 degrees would be in a counterclockwise way. So anytime we move this direction, it's typically denoted as a negative degree movement, or they use the term clockwise, negative or clockwise. And this is positive or counterclockwise. There we go. Okay. So this right here, when a point is rotated 90, 180, or 270 about the origin, you can use the following rules below. And a rotation of 360 will just map it back onto itself. So if you go 360 degrees, you're bringing it right back to where it began. Map the image onto the pre-image, where it began. There we go. It's kind of a messy word there. Where it began. All right, so let's look at that 90, 180, or 270 counterclockwise. Let's look at those rules. Okay, 90-degree rotation. When you rotate 90 degrees, what you're going to do is you're going to multiply the y-coordinate by -1 and then flip it with the x-coordinate. So this is what that coordinate looks like, that rule looks like. And this is what it looks like in reality there. Okay. So let's show you that as an example. Let's see here. Here they've given us that our pre-image is 5,2. And what they tell you to do is to change the sign on your y and then move it forward. So -2 moves forward, and then you move this back 5. That's for a 90-degree rotation. Okay. Now, when you want to think about that in reality, sometimes it's hard to remember which one becomes negative. Or better, which one changes sign. That's a better way to think of it because it might already have been negative. Okay? Think about it this way. If I go from here to here, the signs are plus, plus, and the signs here are what? Negative, plus, right? So if I move 90 degrees, then I know that I'm going to have to flip these. I'm going to have to change the 2 and the 5, and I'm going to have to change to this coordinates, or to this quadrant's sign notation. And down here in the third quadrant, it's negative, negative, and in the fourth quadrant, it's positive, negative. So if you can keep track of which quadrant you're going into, you can also just use the correct signage. Okay, so 180 degrees, the X and Y's stay put, but both change signs. Both change signs. Okay, there you go. So it goes from 5, 2 to negative 5, negative 2. And look at that. When you draw a line back to the origin, because they're both going around the origin, it's a 180-degree line there. Did you notice that up here? That if you draw a line from this point back to the origin and from the pre-image back to the origin, that it makes a 90-degree? That's kind of cool. They're also the same length. There we go. Same down here. Same length. All right. 270-degree rotation. Now here's the rule. Same as the 90, they switch, but now the X is negative. There we go. So if we look here, we've got this distance, and now it's 270 on the outside. There's that 90 on the inside here. And it started at 5, 2, but now they're going to flip. The 2 is going to come to the front, the 5 is going to go to the back, but now the 5 is negative. All right. So let's look at an example. This one says that we're going to do 180 degrees about the origin, and that rule was X, Y, goes to negative X, negative Y. So every single one of these points, you're just going to change the signs. You're going to go negative 2, negative 1, negative 2, negative 1, negative 6, positive 3, negative 1, positive 3, and that will be all of our primes. There we go, all done. Let's see how it goes. There they are. Beautiful. Okay. Now it's your turn to do a 270 rotation. Go ahead and pause me. Let me know when you're done. And did you get A? I hope so.